In this video, we're going to be talking about tangents. Let me tell you a little something about tangents. They are all right. First, let's start with a little bit of a reminder of what tangent lines are. Right? A tangent line intersects a circle at exactly one point, and that point is called the point of tangency. So here's the point right there, and that point's called the point of tangency. A line is tangent to a circle if and only if, right? So this goes backwards and forwards. If it's perpendicular, which indicates that it meets at 90 degrees, to a radius drawn to the point of tangency. So here is our radius, and here's our tangent line, and there's the 90-degree symbol, which indicates that it's perpendicular to the radius, thus a line AB, right? And we're going to use our notation. Line AB is tangent to circle P at point A. So as we move forward, we're going to determine if segment AB is tangent to circle P. So here's segment AB right here. And what we want to know is, does it meet at a right angle? Well, if it does, then we have ourselves a right triangle with side lengths 8 and 15 and a hypotenuse of 17. So we have a squared plus b squared equals c squared. If we place the values in their proper locations, so 8 is a leg squared, 15 is a leg squared, should equal to, opposite the right angle is always the hypotenuse, 17 squared. If this checks out, then we will say yes, AB is tangent. If not, if it doesn't work out, we'll say no, AB is not tangent. So what you need to do is finish this problem off and decide for yourself whether or not that works out. Again, for number 2, same argument. Here's our segment AB, and the question is this a right angle? That makes this the hypotenuse. But the problem is that 5 only refers to this piece out here. What is this piece? It's congruent to the other radius. So this is 11. So the distance all the way across is going to be 16. And this is basically going to be the trick throughout this section of the unit, is paying attention to the radius and where these values lie. So we have a leg of 14, so we'll say a squared plus b squared equals c squared, and then we substitute in the values. 11 is one of the legs, so 11 squared. BP is one of the hypotenuse, I should say, so that's going to be 16 squared. That goes way out there. And then 14 is one of the other legs. Now, one way to remember not messing up where we put the hypotenuse is to pay attention that the hypotenuse is the longest side. And again, if yes, then yes, give me that sentence. And if no, then no, it's not tangent. That's our final answer here, is a sentence that describes whether or not the line segment AB is tangent to circle P. Notice this section of directions changes a little bit. It just says, well, if JK is tangent to circle L, find X. So what we're going to do is work on that assumption that, yes, this is tangent. So here is our hypotenuse, which makes 7, that leg, 19 is that full leg, and X is the hypotenuse. So 7 squared, right, and for the first leg, plus b squared, our second leg, which will be 19 squared, equals hypotenuse squared. And now solve for x, and that's your final answer. Number 4, very similar. A squared plus b squared equals c squared. If we have a tangent situation here, then the right angle would be right there, and that would make this side the hypotenuse. But it's the whole length of that side. So what is that? Well, if this is 11 right here, the radii are congruent to each other. This is 11. So if I take my 11 and 7 and add them together, I get the full length of that side, which is 18. And again, 18 is my hypotenuse. So that's 18 squared equals one of the legs squared plus the other leg squared, which is x squared. Now the difference in these two problems is x is the hypotenuse over here, whereas x is just one of the full lengths of the leg on the other side. So solve for x and record your final answer in your notes. Now, number 5 creates a unique situation. X is referring to this piece over here. And I have this other section over here that I know is worth 10. What we could do is just ignore that for a second and just call the whole thing y. This is where our right angle is, making y our hypotenuse. So when we go to fill in the Pythagorean Theorem, we take a look at what's going on and we say, well, 10 squared, leg 1, plus 24 squared, leg 2, equals hypotenuse squared, y squared. And eventually, we're going to get an answer for y. Now, if we want to know what x is going to be y minus the 10 units that's added into y's value. Right here, x plus 10 equals y. So if I want to go backwards for x, if x plus 10 is equal to y, then if I subtract 10 on both sides, I'll get x is equal to y minus 10. And that's how we're going to solve for the x value. First solve for y, subtract 10, and you'll have your value for x. Again, this is about, a way of thinking, right? That's what we're trying to think about in geometry. It's not just the algebra and the geometry itself. It's all about training your brain to think outside the box and look for unique solutions to unique problems. I won't bore you too much with question 6 other than here's our right angle, there's our hypotenuse, and this leg is x, the hypotenuse is 25. How long is MJ? Think about this. Only this portion is 11. What's the other portion? And then what's the whole leg worth? Pay close attention to that one. Think it through. You can do it. A couple other random problems again. Here's LJ, that's 3.5. And keep in mind these are both radiuses or radii. So this is 3.5 here. And when we think about the Pythagorean Theorem, here's the right angle, which makes this the hypotenuse. And when you go to do a squared plus b squared equals c squared, when you go to substitute in your values, be careful to think about the whole length of MJ as a leg and the whole length of JK as a leg. Those whole lengths go right here, and they're going to be set equal to x squared. And then you can finish getting an approximate value for x on your own. Again, for number 8, we have our right angles right here, making 25 the hypotenuse. I have x here and x here, so rather than use x plus x as the length, let's call this y. And now y is going to be the length of a leg. So we're going to say y squared plus 7 squared, because those are our legs, equals the hypotenuse squared, 25 squared. And eventually you should be able to solve for y. Now once you get that answer for y, how many portions does it take? How many portions of x does it take to make y? There's 2x equals the value of y. So how do we get the value of x? Undo that by dividing by 2. So x equals y divided by 2. So once you solve for y, you're going to take that answer and divide by 2 to get the value for x. It's about thinking creatively. Now that you've had some time to practice with the idea of being perpendicular at that point of tangency, we want to talk about a few other properties that have to do with tangent lines. And the first property has to do with two segments, right? Two segments from the same external point. So that would be coming from B would be that same external point. If they are tangent to a circle, then those segments are congruent. So segment AB and segment BC are two segments that are tangent. If you notice, they are tangent because I see that they are perpendicular to the radii. If that's the case, then those segments are congruent as stated right here. Next, we have the idea that a polygon is circumscribed. So circum means to go around, and scribe means to write. So when we talk about circumscribing, we're talking about writing around. So if a polygon is circumscribed around a circle, then all sides are tangent. So when we're looking at this triangle, this side AB is tangent, thus making D a point of tangency. And then side BC is also tangent, making point E a point of tangency. And lastly, segment AC here is tangent at point F. Now, if these are all tangent at those moments, let's think about this. We have an external point, so we think about back over to here. A is the external point, and it's tangent to the circle on both sides. Thus, segment AD and AF are congruent. Point B, external point. DB, EB, congruent. Point C, external point. EC and FC are congruent. Okay, so let's put this into action, see how this works out. Numerically and algebraically, of course. So what do I see? I see that they want me to find the value or measure, and we can assume that the segments that appear to be tangent are tangent. So it appears that we have points of tangency right here. So I can assume that they are. Now, what do I know? I know that I have this external point and that these two segments right here are congruent. So what can I say about the two algebraic components? 14x minus 13 must be equal to 8x plus 5 because they're congruent. If they're congruent, I set the terms equal, and then I can solve for x. Once I solve for the value of x, I can find PQ by substituting x in, and I'll get that PQ is equal to some length, and you can finish that on your own. Number 10 is very similar, only all you have to do is just solve for x. You don't need to find the length of a side. For number 12, our approach is going to be very similar. So they want us to find the length of SV, and SV is this segment right here. And what I know is, or my assumption rather, is that we are tangent at point T, which makes this the hypotenuse. So I'm going to look at this as a right triangle and use my Pythagorean theorem, a squared plus b squared equals c squared. The problem is that I don't know the length of ST, but I have a way to get it. So I know that ST is congruent to SU. So first things first, I know that if congruent, set the terms equal. So 10x minus 41 equals 4x plus 7. So I'm going to go through the algebra, and I'm going to arrive at a value of x. Now I'm going to take that value of x, and I'm going to substitute it in right here, and that will give me the length of ST. ST squared, of course, you're going to actually place the length of ST, right? You're going to have an actual hard number right there. Squared added to the other leg squared, 17 squared, is equal to my length of SV squared. So let's call that y squared. And y is going to be equal to the length of SV. So once you find the value of y, you will have found the value of SV. So just to repeat that, we have our algebra statement that started with the idea of an external point being equidistant to the two tangent points. That allows us to solve for x. Once I have the value of x, I have the length of ST, which is one of the legs of my right triangle that I'm going to use the Pythagorean theorem for to solve for the missing side. So lots of work to be done there. The good news is we're very close to being done with our problems. So I take a look here, and they're asking us to find the perimeter of the quadrilateral PQRS. So that's this quadrilateral right here. We'll notice that number 13 is very similar Right? We have a problem 13 that's very similar to this problem. So let's take a look. We have external point P, and it is tangent at this moment and at this moment, making these two pieces identical. And as I go around, I have external point Q, making these two lengths identical. And over here, I have point R, making these identical. And then to be just a touch redundant, 1, 2, 3, 4, 1, 2, 3, 4, S also tangent at these points. So we're just going to do a little bit of subtraction and or addition to see what's going on here. So if this piece is 27.1, then this section right here is 27.1. The whole length is 52.5, so this section right here is going to be 52.5 minus 27.1. So that's that section. And then this section is identical. Then I have this length is 23. So this length must be 23. And this length right here must be 37.5 minus 23. And so is this piece. Once I have all that, I'm just going to take my full lengths. Right? We don't know what this is, but this is going to be 23 plus something. Perhaps it's a little misleading, so I'll redefine this side as, I don't know. But I know it's going to be 23 plus whatever this number is. 52.5 is the length of this side. And then we need the whole length over here is going to be the 27.1 plus whatever this length is. And that will go right here. And then I'm just going to add 37.5, 52.5, this question mark value, this question mark value, and I will have the perimeter of PQRS. Piece of cake. After you're done with problems 1 through 14, what we'd like for you to do is to practice some algebra. And so this may have to be wrapped up as homework if you ran out of time. And you just have these 4 problems to do. So first, the hint, right? And we're going to do this on separate paper. So you're going to need to get some separate paper of your own to work on. The next thing we're going to do, or on step 1, is, or number 1 rather, is to distribute the 8, distribute the 2, and then move things around and solve for x, right? This is just basic algebra review. On number 2, there's a -1 right here, so we're going to have 167, and as I distribute that -1, what happens? I'm going to get a minus 7x minus 3 equals 108. Maybe some combining like terms has to happen, and then solve for x here. Over on number 3, if we put 47 over 1 and cross multiply, we're going to get 2 times 47 is equal to all this mess times 1, which is just going to be all that mess. Combine like terms on the right side and solve for x. And then the last one, number 4, we're going to cross multiply. And again, we have a little bit extra here to do. First, we need to realize that this is an implied parenthesis. So as I multiply 2 times that 2x minus 7, I want to distribute that 2. As I multiply the 1 times all this mess, it's going to be all that mess. But we're going to have 8x minus 47. And again, just like in the problem up here, I have a -1. So as I distribute that -1, it's going to be minus 3x. And as I distribute that -1 again, I'm going to get plus 14. So just some helpful hints. Combine like terms. Distribute the 2 over here. Move some stuff around. Whoops, I dropped the pen. But I will tell you this much about the answers. They're all whole number answers, right? These are whole number answers. Good luck, and we'll see you next time.